Hello friends, welcome to Learner's Planet. Friends, in this session I am going to take doubts based on time and distance and time and work. And I would recommend you to just attend the basic sessions of time and distance and time and work before you come for this particular session. And just be ready with your paper and pen so you start solving the problems right with me. Okay, so let's begin the session. Now this problem. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 km along the shortest possible path in 15 minutes. What is the velocity of the river? See here, what is the distance that is it has to cover? That is 1 km. So distance is 1. So distance by speed is equal to time, or speed is equal to distance by time. So distance is 1 km and time is 15 minutes. I convert this 15 minutes to hours, so that's 1 by 4 hour. So that is actually speed of the boat, right? So speed of the boat is actually what? The effective speed of the boat is speed of boat plus or minus speed of river. So that is 5 plus minus speed of a river, I assume to be say x. Okay, now I don't know whether it will be plus or minus, so let's see what happens. 5 plus x is equal to 4, so obviously x cannot be negative, so x has to be positive. That means we'll eliminate this. So it is 5 minus x is equal to 4, so x is equal to 1 km per hour. That is the speed of the stream, or we can say speed of the river, right? When you are going upstream, the effective speed is difference of the speeds of the boat and the river, and when you are going downstream, the effective speed is the speed of the boat plus speed of the river. But in this case, nowhere it is given that the speed of the whether this boat is going upstream or downstream, right? But we can get this idea from here, because the effective time, that this 5 plus minus x is equal to, that is the effective speed, maybe plus maybe minus, is equal to distance by time. So here time is 15 minutes, that means 1/4 of hour. So 5 plus minus x is 4. Now x cannot be negative, so here we have to eliminate the positive sign. So x is equal to 1 km per hour. 5 plus x is 1, not possible. Okay. Now this problem, from time, speed and distance, the average speed of a train in the onward journey is 25% more than that of the return journey. The train halts for 1 hour on reaching the destination. The total time taken for the complete to and fro journey is 17 hours, covering a distance of 800 km. The speed of the train in the onward journey is. Now precisely, if we deduct that 1 hour that the train is taking halt at the station on reaching the destination, the total duration of this to and fro journey is 16 hours, right? Now what? See, total duration is 16 hours. Now average speed in the onward journey is 25% more than the return journey. That means the ratio of speed in onward journey to a return journey is 5:4, right? That is 1 plus 1 by 4. 1 by 4 is 25%. So in suppose in return journey, if the speed is 1, then in onward journey it is 1 by 4 more, that is 25% more. So that is 5 by 4, right? So onward is to return, the ratio is 5 by 4. So speed ratio is this, that means time ratio will be this. Okay. So breakup of 16 will be done in the ratio 4:5. But we have to find out the speed of the train in onward journey. So in onward journey, it is completing 400 kilometers in 4 by 9 hour. I'm sorry, 4 by 9 part of 16. The total duration is 16. So 4 by 9 of 16 is the total time, and the total distance is 400 kilometer, because total is 800 to and fro. So one side it is 400. right? So it is 25 into 9 by 4. Obviously cannot be an integral value, so it's 25 into 9, 225 divided by 4, 50, more than 50. So we have just one option, that's more than 50 over here. Okay, so pretty clear. I just explain it once again. The ratio of speed is 5:4. That means the ratio of time will be 4:5 because speed is inversely proportional to time. Now total time is 16 hours. So on the onward journey, the time will be 4 by 9. The total time 4:5 is actually 9. But actual timing is 16. So on onward journey the time will be 4 by 9 of 16, and for the return journey the time will be 5 by 9 of 16. But since we have to find out the speed of the train in onward journey, we'll be taking time as 4 by 9 of 16, and the total distance that it has to cover in onward journey is 400 kilometer, right? So speed is equal to distance by time. So that is 25 into 9 by 4, 56.25 kilometer per hour. Okay. A person travels from X to Y at a speed of 40 and returns by increasing speed by 50%. What is the average speed of both the trips? See, if the distance is same, then the average speed is actually the harmonic mean of both the speeds, right? Here the first speed is 40 and the other will be 60. Obviously 50% it is more than the previous ones. So what's the harmonic mean of 40 and 60? That is 240 into 60 by 40 plus 60. So that's 2 into 40 into 60 by 40 plus 60. Okay, precisely why it is happening you should be logically clear also. You can learn the formula, but you should be logically clear. Now what is happening, that actually average speed is what? Total distance by total time. Average speed is total distance by total time. Now here we don't know the distance, but the distance between X to Y is same as Y to X. I assume that distance to be say X. Okay. So X distance it is covering at the speed of 40. So this much is the total time. Then X speed it is covering with the speed of 60. So this is the total time, right? So this X by 40 plus X by 60 is the total time, right? What is the total distance? That is 2x, because we assume one way distance is X, so the total distance is 2x. Now if you can take X as common and you can cancel it, so what you'll be getting? 2 into 40 into 60 upon 40 plus 60 if you take LCM. So you're getting the same thing. Okay, so you can learn the formula, or you should be definitely clear with the logic, right? So your answer is 48 kilometer per hour over here. Now let's see this problem. A worker reaches his factory 3 minutes late if his speed from his house to the factory is 5 km per hour. If he walks at the speed of 6, then he reaches 7 minutes early. The distance of the factory from his house is. See what is happening. I assume the distance to be x kilometer, right? Now what is happening? X kilometer. If he goes x kilometer by the speed of 5 km per hour, he takes less time, and if he walk at the speed of 6 km per hour, he'll take, okay, if speed is more, time will be less. So in this case he'll be taking the less time. So x by 5 minus x by 6. X distance with 5 km per hour, this is the time. X distance with 6 km per hour, this is the time. So the difference between the two time is, in this case he is 3 minutes early, and in this case he is 3 minutes late, and in this case he is 7 minutes early. So 7 minutes early and 3 minutes late. So mutual difference is actually 10 minutes. Okay, suppose this is the normal time. 7 minutes early and 3 minutes late. So mutual difference between these two is 10 minutes. I convert that to R. So that's precisely 6x minus 5x. That is x by 30 is equal to 10 by 60. So x is equal to 5 km. Okay. Now see this problem. A conveyor belt delivers baggage at the rate of 3 tons in 5 minutes, and the second conveyor belt delivers baggage at the rate of 1 ton in 2 minutes. How much time will it take to get 33 tons of baggage delivered using both the conveyor belts? Now that's pretty simple. See what is happening. The first the rate of the first one is 3 tons in 5 minutes. So what we can do is we can find out the per minute amount transfer, that is baggage transfer, right? So 3 tons in 5 minutes, that means per minute it is transferring 3/5 of the ton, right? Per minute it is transferring 3/5 of 1 ton. Okay. Similarly, the second one is transferring 1 ton in 2 minutes. That means precisely it is transferring 1/2 ton per minute. Right? The first one 3/5 in 1 minute, the second one 1/2 in 1 minute. So in 1 minute the total amount ton transferred is 6 plus 5, 11/10. So in 1 minute 11/10 ton is being transferred. So in all we have 33 tons. So how much time will we take? 30 minutes. Okay, pretty simple. That is 11/10 ton per minute. Okay, and we have 33 tons. So we'll take 33/11 into 10, that's 30. Okay, I hope you are clear. Now we see this problem. Two ladies simultaneously leave cities A and B connected by a straight road and travel towards each other. The first lady travels 2 km per hour faster than the second lady and reaches B 1 hour before the second lady reaches A. The two cities A and B are 24 kilometers apart. How many kilometers does each lady travel in 1 hour? Now here among the options, both we have been given the kilometers traveled by each lady. So the problem becomes very simple. You don't have to touch even your paper and pen. See, in all the options, the difference between the distance is 2 km, right? So we cannot eliminate even a single option by this way. But what we can do is, see, the distance between A and B is 24 km, right? Now, and one lady is taking 1 hour more to cover up that distance. Okay, so what we can do is suppose we choose option A, right? If this 24 kilometer is the distance and the speed of how many kilometer does each lady travel in 1 hour, that is precisely the speed of the ladies. Okay, so if the distance is 24 kilometer and the speed is 5 kilometer per hour, then the time will be 24/5. So that is actually not integral value. That is, so it's a fractional value. So what we do is we try to choose an option which produces integral value, right? That is option C over here, right? So what we can do is, now we just go for the cross verification. So 24/8, right? 24 is the distance to be covered up by the lady, and if the lady covers 8 km per hour, so she will take 3 hours to cover up 24 km, right? And the other lady will take 24/6, that is 4 km. Okay, so the difference between these two is 1 hour. So that is the cross verification, because the difference between the time taken by the two ladies is 1 hour, right? So that problem becomes very simple. You just have to give it a thought. Okay, how many kilometer does each lady travel in 1 hour? Precisely it is the speed of each lady is being asked. Both the options like 5 km per hour, 3 km per hour, it's both the speeds are given. So the problem becomes very simple. Okay, if you are not clear with the explanation for the first time, then just go for a recap. Okay, now see this. A car travels the first 1/3 of a certain distance with a speed of 10 km per hour, the next 1/3 with a speed of 20, and the last 1/3 with a speed of 60. What is the average speed of the car for the whole journey? See, average speed is always the total distance by total time. Okay, that I have just explained in one sum. Total distance by total time, right? So here I assume the 1/3 distance to be 60. Now each of them is covering the same distance, right? 60 it is covering, 60 it is 60 with the speed, 60 with the speed, and 60 with the speed. So the total distance is actually 180, right? So with the 10 km per hour speed, if it has to cover 60 km, it will take 6 hours, right? In this case it will take 3 hours, and in this case it will take 1 hour. So this is the total time. And what is the total distance that has been covered up? 180 kilometers. 60, 60 and 60. 60 kilometers at the rate of 60 kilometer per hour, 60 kilometer at the rate of 20, 60 kilometer at the rate of 20. So this is the total distance, that is 180, and that is the total time. 6 plus 3, 9 and 1, 10. So precisely average speed is 18 kilometer per hour. Okay. Now we see this problem. Total time taken by a person is in going to a place by walking and returning on cycle is 5 hours 45 minutes. He would have gained 2 hours by cycling both ways. The time taken by him to walk both ways is. Now this problem can be done mentally. That's just very simple. See what's happening over here. This person is taking walking plus cycling is 5 hours 45 minutes. Right, but cycling plus cycling is 3 hours 45 minutes because he is gaining 2 hours. Right, now what is that? This 45 minutes is actually a complicated figure, so what I do is I just convert the entire thing in minutes. So 5 hours means 300 minutes, so precisely it is 345 minutes. Right, now what is there? Cycling plus walking is 345 minutes, but cycling plus cycling is 2 hours less, that means 120 minutes less, or we can say 3 hours 45 minutes. So that's 180 plus 45, 225 minutes. Now what? Cycling plus cycling is 225 minutes. That means one-way cycling will be 225 by 2. So I put one-way cycling over here, 225 by 2. So I'll be getting one-way walking. So one-way walking is 345 minus 225 by 2. So two-way walking will be double of that. Okay. So 2 into 345 is 690, and 690 minus 225 is 6, 700, 225, that's 465, right? So 465 minutes it will take if he walks both the ways. So that's divided by 60. So 7 hours 420 minutes, then 45 hours 45 minutes left. So that is 7 hours 45 minutes. Okay, I just go for a quick recap. See, if we walk plus cycle, that's 345, I'm sorry, 345 minutes. Then if he cycles plus cycles, then it is taking 225 minutes. So one way cycle will be 225 by 2. So I put 225 by 2 over here. So I'll be able to get one way walking. So two way walking will be double of that. Right? Just try to reduce the calculation. Do not write the things one and again. What I'm doing is I'm just cancelling the thing and just rewriting the equations. Okay? Like you can see over here. Okay? So this way you'll be able to save time. And if the data is simple, like instead of 5 hours 45 minutes, if it had been 6 hours suppose, right, then you don't even need the paperwork, right? If it is 6 hours, then in the other case it is if cycling plus cycling will be in that case 4 hours because he is saving 2 hours. So cycling plus cycling, two-way cycling is 4 hours, that means one-way cycling is 2 hours, right? And one-way cycling is 2 hours, that means one-way walking is 4 hours. So one-way walking is 4 hours, so two-way walking is 8 hours, right? Now what we have done is we have increased for 15 minutes over here, right? So one-way, two-way walking will be 15 minutes less. Okay, so that's why 7 hours 45 minutes. I got 8 hours two-way walking. If I make it 5 hours 45 minutes to 6 hours, so if I get 8 hours, so this 15 minutes difference will be produced over here. Okay, so I'll deduct this 15 minutes. So two-way walking is 7 hours 45 minutes. You can go this way also, right? Two cars X and Y starts from two places A and B respectively, which are 700 kilometers apart at 9 a.m. Both the cars run at an average speed of 60 km per hour. Car X stops at 10 a.m. and again starts at 11 a.m. while the other car Y continues to run without stop. When do the two cars cross each other? Okay, so that's pretty interesting problem. So this is the route which they have to cover up. Okay, This is the place X, A and B. Right? Now both of them are leaving at 9 a.m. Okay, and the car X stops at 10 a.m. Suppose car X is starting from this side and Y is starting from this side. After 1 hour, what will be the situation? See, initially this is 700 kilometers. After 1 hour, it might have covered up 60 kilometer, it might have covered up 60 kilometers. So this is the present situation. Okay, that at 10 o'clock. At 11 o'clock, this car will still be here and this car might have covered up 60 kilometers more. So this is the situation at 11 a.m. Okay. Now the present scene is at 11 o'clock. The distance between these two is 60, 60, 60, 180 hours, 180 kilometers less than 700. Right. So this is precisely 520 kilometer. At 11 o'clock, the distance between these two cars is 520 kilometer. Now since they are approaching each other, that means coming from opposite side, so the relative speed will be 60 plus 60. That means per hour they will be getting closer by 120 kilometer, right? So how much time will they take to meet? That is total distance which has to be covered up, that is 520 kilometer, and the relative speed is 120. Okay, so 13 by 3 hours. Okay, or we can say 4 hours, 1 by 3 hours, right? Or we can say 4 hours and 20 minutes. So after 11 o'clock they are meeting at after 4 hours and 20 minutes. So 11 o'clock plus 4 hours, that is 3 o'clock, and then 20 minutes. So they will be crossing each other, or they'll be meeting each other at 3:20. Okay, I hope you are clear. Now see this problem based on relative speed. A thief running at 8 km per hour is chased by a policeman whose speed is 10 km per hour. If the thief is 100 meter ahead of the policeman, then the time required for the policeman to catch the thief will be. So we have already discussed this sort of concept, that is a relative speed concept, in my basic time, speed and distance session. Here what is happening, the thief is running at 8 km per hour and the policeman is running at the speed of 10 km per hour. That means for every hour the policeman is running 2 km more, right? So what we can say, his gaining speed is 2 km per hour. That means every hour he is gaining 2 km. Okay, now what is happening, suppose diagrammatic representation, if we say the policeman is here and the thief is here and the distance between them is 100 meter. Now policeman can run 2 km per hour extra, right? Policeman can run 2 km per hour extra. Now to catch this thief, he has to run just 100 meter extra, right? Because thief is also running, policeman is also running. So we are taking the relative speed, that is 2 km per hour. Okay, so 2 km per hour with the speed of 2 km per hour, if he has to gain 100 meter, how much time will it take? So that is 100 by, and what you can see is 2 km per hour. So to gain 1 km, that is 1000 meter, he'll be taking 30 minutes, and to gain 100 meters he'll be taking 3 minutes. Okay, I just go for a quick recap. The difference between their speeds is 2 km per hour, that is the gaining speed of the policeman. The policeman can run 2000 meter per hour extra. So 2000 meter per hour, that means to run 1000 meter he will take, to run 1000 meter extra he will take half an hour, that is half of 1 hour, right? But instead of 1000 meter he has to gain just 100 meter, right? So we'll remove one more zero. So instead of 30 minutes he'll be taking 3 minutes. Okay, so that's pretty simple. And if you are finding it difficult, what you can do is, his gaining speed is 2 km per hour, or I can say 2000 meter per hour, right? So he has to gain 100, so 2000 and into 60 to convert hour into minutes. So it's 3 minutes. Okay. Now let's see this problem. A train travels at a certain average speed for a distance of 63 km and then travels a distance of 72 km at an average speed of 6 kilometers more than its original speed. If it takes 3 hours to complete the total journey, what is the original speed? I assume the original speed is x, right? Now what is happening? For 63 kilometers it is running with the speed of x, so it is taking this much time, right? Plus a distance of 72 kilometers, it is running with the speed of 6 kilometer more. That means x plus 6 speed, and this total time is actually 3 hours. Okay. Now you have got this relation. Now obviously you just cannot make a quadratic equation over here. What you will do is x plus 6 into 63, x into 72, or what you can do is 63 and 72 can be taken as common and you can do it 1 over here. So I just do it 1, and this is 21 and this is 24, right? Still you have to make a quadratic equation, and that will be a lengthy, tedious, time consuming and space consuming process. So what I suggest to you just can go by options. So what I do is, instead of making quadratic equation, we leave the relationship as it is. Now we go by option. Suppose I choose 24. Now 63 by 24, that is around 2.5 hours. I'm not just getting actual duration, around 2.5 hours, and 24 plus 6, 30, 72 by 30 is more than 2 hours. So the total duration will cross definitely 4 hours. Okay, 4 or 5 hours, but we have to get 3. So that's incorrect. Okay, 33 is very weird number because 63 by 33 it will leave 11 in the denominator, and here it is 33 plus 6, 39, it will leave 39 in the denominator. So we cannot get the common factors to get an integral value. So we leave this, right? 63 by 66 less than 1 hour, 72 by 66 around 1 hour. So both of them will not make 3 in any case. We just go for the cross verification of 42, 63 by 42, 21, 3 and 21, 2, and this 42 plus 6, 48, 24, 2, 24, 3. So 3 by 2 plus 3 by 2 we are getting 3. So 42 is the correct answer. So do not make quadratic equation. It will be space and time consuming. Okay, just try to get the round idea as I am doing over here.